Morning, grade 10. We are still in the activity part of Module 1, weeks 1 to 4. Currently, as what I had promised, we will be having different examples. We'll be having a series of examples by this time, right? So how can we identify? The question there is, how can we identify certain problems and link it with certain concepts? Simple, okay? Let's have this example, okay? The one we had tackled last meeting. Okay, let me open it. Okay. Let's have this one. Okay. Okay, the question here, or the problem here, is actually asking about a balloon initially has a volume of 0.4 or 0.4 liters and a temperature of 20 degrees centigrade or Celsius. What will be the volume of the balloon after it is heated at 250 degrees centigrade? Since we're talking about, okay, first and foremost, you need to look for what are being asked in that certain problem. So it is asking about volume, correct? Okay, it is asking about volume. Now, because it is asking volume, okay, it is also talking about what? As what you had observed there. Volume and it is talking about volume and here, temperature. Okay, yes, volume and temperature. It's actually talking about volume and temperature. Now, what are the concept, or what is the concept involved, or the relationship between volume and temperature, or what concept is actually talking about relationship between volume and temperature based on what we had discussed. It is actually in your LMS, okay, under the module handout copy. What do you think are the concept there that talks about the relationship between volume and temperature? Hold on. Let me fix this for a while. Okay, going back to the discussion. What do you think is the concept that is actually talking about volume and temperature based on what we had discussed? What concept? It is under what? It is under. Yes, you can use the chat box if you want. Okay, I want answers from you. This is now the analysis. Okay, you need to analyze on the problem, what is being asked in the problem, and right after you can actually get the information about certain concepts. Was it Charles law? Okay. Any other answer? Let's check it later. How about any answers? Any other answers? Yeah. Charles law is talking about volume and temperature. So after you actually identify what is being asked there or what concept is involved, what should be done next? What should be done next? You already identified that this problem is talking about Charles law, which is true, okay? Because Charles law is concerned about the relationship between volume and temperature. According to Charles law, again, you actually what? You actually talk about what? That volume and temperature is directly proportional. Okay? Say directly proportional. If volume goes up, the temperature also goes up. That's proportional, being proportion. Okay? What should be done next? Substitute. Yes. We can now, since we already know the concept behind, we can now substitute. But before anything else, we need also to identify what are the given in that particular problem. So you identify the given. There's a problem with my keyboard again. You identify the given. Okay, what are the given there? What are the given? Okay, 0.4 liters. So this is what? Belongs to what? Okay, the question here is what will be the volume of the balloon after it is heated at 250 degrees centigrade. So this is volume 1, this is volume 2. Okay, the question there is volume 2. Correct? Since then, because we have two volumes here, okay, we can actually use what? V volume 1 or V1 is equal to 0.4 liters And we have also two temperatures here, okay? Which is 20 degrees centigrade and 250 degrees centigrade. So this is T1. Temperature 1 is 20 degrees centigrade. Let me copy this one. How about V2? Okay. Again, we have two volumes involved here. Okay. Based on the problem, you can actually identify those. Okay. This initially, okay, if it is initial, this is V1. Okay, initial. Initial and final. Okay. Other books, they are actually using BI and VF. Okay. Volume initial, volume final. Okay. But in Charles' law, the formula for the equation between volume and temperature, since this is directly proportional, this is V1 over VT1 is equal to, because they are directly proportional, okay, is equal to V2 over T2. So meaning to say that both are equal, supposed to be. Okay, let's take a look at this one. So V1, this is V2. Question mark, because this is the unknown. Okay, and we're talking about this. What would be the volume of the balloon after heated up to 250 degrees centigrade? The 250 degrees centigrade here is considered as the T2, or the temperature 2, or final temperature. Okay, since we already identified what are the given, we can now substitute. Okay, we can now what? We can now proceed in the formula. Okay, we can now proceed to the calculations. Okay, formula. This is V1 over T1 is equal to V2 over T2. Wait lang ha. There's a problem with my keyboard. So this is now the formula. T1, V1 over T1 is equal to V2 over T2. So let's substitute now. Okay. According to the given, okay, we have the V1, which is 0.4 liters. Okay. Over T1. What is our T1 there? Over T1, which is 20 degrees centigrade. Are you still with me? Are you still with me? Okay. Is equal to V2, because the V2 there is unknown. Let's just put there V2 over underline T2. So the T2 here is the final temperature is 250 degrees centigrade. Okay. What should be done next? We already identified, we already include or justified everything. Okay. We incorporated what are the given. What should be done next? Okay. What should be done next? What should be done next? Right? So if you're going to look at Charles' law, okay, Charles is actually using Kelvin, and we are still using degrees centigrade. How can we convert degrees Celsius into degrees Kelvin? Okay, conversion factor. The conversion factor for degrees Celsius in order to be converted into degrees Kelvin is only what? This is the constant, okay? Plus, this is the constant, okay? You are actually, we usually discuss this one during grade 6, okay? Conversion factors for temperature. So if we're going to convert degrees centigrade into degrees Kelvin, we just add 273, okay? And there you go, you can convert that one into degrees Kelvin. So T1 is equal to 293 Kelvin. And T2 is equal to T2 is equal to 250 plus 273. 523 Kelvin. Again, MD, where did you where did we get the 273? Okay, this is actually discussed when you were still in grade 6. This is the conversion factor. Okay, this is constant wherever you go. The 273 is always linked with Kelvin, right? It is always linked with Kelvin. So if you're going to convert, again, degrees Celsius into Kelvin, you add 273 in order to be converted into degrees Kelvin. That's constant. Okay? Conversion factor. Just like when you have your time ba, okay? 1 hour is equal to 60 minutes. Where did you get the 60 there? That's the conversion factor. Okay? Same with Kelvin. Okay, let's move forward. Okay, let's convert this one into degrees Kelvin. Oh my God. Okay, we already converted degrees Celsius into Kelvin, so we can now substitute. So what should be done next? What should be done next? What should be done next? Okay, we are now down to the calculations. Okay, we are now in the what? In the mathematics side of science. This is mathematics now. So what should be done next? Any idea? My keyboard is running again by its own. Okay, any idea? Cross multiply. Correct. That's a good idea, Margie. Yes, we need to cross multiply. Why? Because you cannot substitute if there is unknown there. Okay? You cannot actually substitute if there is unknown there. So you need to cross multiply. So let's have this one. I will put a remark here. Okay, let's have a shape. Right? Cross multiply. Mm. Okay. Cross multiply. And that's it. Okay. This is the mathematics side of science. So crossing it over will mean what? So this will become what? Go. Any idea? So let's cross multiply this one. So what will be done next? Hmm? Oh my God. Wait, huh? Cross multiply na. So it will look like this one. Wait, 0.4 liters times 523 Kelvin, okay, is equal to V2. Of course, multiply man, diba? Right? Okay, V2 times 293 Kelvin. Okay, what should be done next in order to isolate V2? What should be done next in order to isolate V2? You're done with cross multiplication. Okay, we need to isolate, we need to extract V2. Okay, in the formula or in the calculation there. What should be done next? Okay, this is basic mathematics. We need to what? In order to cancel this 293, okay, we need to divide it by itself with 293. Combining? We cannot combine. Okay, we need to divide it by themselves. Divide it by 293. Are you familiar with this formula? It is in mathematics. Okay. Once you divide it by themselves, you can actually cancel this one. You can now cancel. So we did isolate V2. Are you following? Are you still with me? Are you still with me? Okay. So we did isolate V2 in the process. Why? We canceled 293. Okay. So what should be done next? The V2 now is isolated. V2 is equal to, we already isolated it, correct? 0.4 liters times 523 Kelvin over 293 Kelvin. Okay. Cancel like terms. What are the like terms there? V2. What are the like terms there? You can actually observe some like terms there. You can cancel it over. Okay. Equal to 0.4. Let me copy this one. Cancel like terms. What are the like terms there? Okay. We can actually cancel what? degrees Kelvin in the process because these are like terms. So it actually boils down to V2, still have 1 minute left. So let's make it faster. V2 is equal to 0.4 liters times 523. What could be the answer? 0.4 times 523. 209.2. 209.2 over 209.2 over 293.